1.6, we talk about probabilities. So you should have done this whole thing from page 39 with a partner, dropping a note card, answering some questions. Okay, everything that you just did, that's what we're dealing with today. So first of all, let's just define probability. Probability is how likely an event is to occur. Probabilities can be expressed as percents. So percents, they go from 0% through 100%. Or as real numbers. And in that range, we go from 0 to 1. For an impossible event, so it will never occur, the probability is 0 or 0%. Okay, so this is our real number, this is our percent. For a certain event, so it's definitely going to happen, no chance that it's not going to happen, our probability, we would say, is 1 or 100%. All right. Now, specifically, we're going to talk about two different probabilities. The first one is experimental probability. Experimental probability applies when you have taken data from observations to calculate the probability. Okay, so we actually take data from things that have happened and we calculate the probability from that. Each observation is called an experiment or a trial. The experimental probability of an event, the notation for that, the way we write it, is capital P of event. Okay, so that's how we say that we're doing the probability, experimental probability of an event. And what that equals is the number of times the event occurred over the number of trials. All right, so that's like what we can take experimental probability from the note card drop experiment that you did before, okay? So say you want to know, we're talking about the experimental probability that it landed on its long side. So how many times did it land on the long side? Okay, you would put that over the number of trials. Okay, so for the first round when you dropped it 50 times, okay, the number of times it landed on its long side over 50. That would be the experimental probability of the event that it would land on its long side. Let's do this example. All right, when the University of Texas won the college football's national championship in the 2006 Rose Bowl game, does anybody remember that? Y'all weren't very old. Its quarterback, anybody remember who that was? Completed 30 of 40 passes. Find the experimental probability of the quarterback completing a pass. Okay, so remember, it's experimental probability. We take numbers from things that have already happened and we create the probability out of that. So our event that we're talking about, what do we want to know happened? We're talking about completing a pass, so we'll call that completion. So our event is completion, and the probability of the completion is the number of times it occurred over basically the attempted, the total number of trials. Okay, so how many times was the pass completed? 30 times. How many passes did he throw overall? The attempts for completion was 40. So you can put that in the calculator. We find that it's 0.75. So that's the probability expressed as a real number, or we could put it as a percent. It's 75%. All right, so take the number of times it occurred over the attempted, reduce it, get it in a decimal or a percent. Either one works. On the back side of the notes, we're talking about our other kind of probability, which is theoretical. Okay, so theoretical, we're predicting what will happen. It hasn't happened yet, we're just predicting what will probably happen. Experimental, we're talking about what already did. So when you roll a number cube, when it says number cube, your book says that sometimes it's talking about a dice, okay, one of these things. The possible outcomes are 1, 2, 3, 4, 5, and 6. We're talking about a regular cube. I know there's weird, crazy ones, but we're talking about a 6-sided cube. The set of all possible outcomes is called the sample space. So for a cube, the sample space is 1, 2, 3, 4, 5, 6. Theoretical probability is a ratio of outcomes. It's a prediction, okay? That's what theoretical probability is. It's a prediction. Theoretical probability. Okay, this is basically what it is, how we set it up. If a sample space has n equally, that's important, they have to be equally likely outcomes, and an event A occurs in m of these outcomes, then the theoretical probability of event A is the number of favorable outcomes over the number of possible outcomes. Okay, so the way we'd write this is the probability of event A is the number of possible outcomes, so that's the n. Okay, so for our dice up here, that we have 6 different outcomes that could happen, so 6 would be on the bottom. And then the number of favorable outcomes, those are the ones we want, okay, and that just depends on what we want, okay. So the bottom is the number of total possible outcomes. The top is the favorable outcome, so the one we want. And we write it like this. So let's do an example, and then we'll be done with notes, and you can do your homework. Find the theoretical probability of getting an even number when you roll a dice. So what are our even outcomes? 2, 4, and 6. All right, those are what we want. So remember that we're going to do probability of A equals n on bottom, m on top. Well, first of all, A is what we want, and what we want to get is an even. Okay, n is number of all possible outcomes. So possibilities, I'll just do that. Okay, and we already said there's 6 possible outcomes when we roll a dice. M is our number of favorable, so that means our even outcomes. And how many even outcomes do we have? 1, 2, 3. 1, 2, 3. We've got 3. So now we'll just plug it in. So P of even, the probability of even is n goes on bottom, so that's 6. 3 on top. Reduce it, we get 1/2. So that is the same thing as 0.5, or what percent? 50%. So our answer would be these two. So when you roll a dice, the probability that you're going to get an even number is 50%, or 0.5. 0.5 out of 1. All right? So figure out what you want. Figure out the number of total possibilities on the bottom. That's good and bad. What we want, what we don't want, goes on bottom. And then the number of what we want, so how many options are there for what we want, goes on top. All right? And then you just reduce. If you have any questions, I know Miss Landis will be happy to help. Okay, you've got several problems to do on your homework. Go ahead, get done, so maybe you don't have homework over the weekend, because I know all of you keep complaining about that. So, do it.